So some of the apps that we've built, we've helped build apps that you might be familiar with, including apps for individual founders, startups, and Fortune 500 brands. Some of the ones that we like to call out are The Atlantic and The New Yorker. We built their flagship iOS apps. We did design for Mastodon across iOS, Android, and web. We worked with House Party, Clubhouse, Jet.com, and many, many more names that you'd know. But enough about us. I'd like to now hand it over to my colleague Ken to go over our agenda for today and to jump into the talk.
Thank you, Matt. Here's the agenda for today. We're going to cover a lot of stuff, but first, we're going to introduce some basic terminology. We're going to give you a broad overview of the technologies we plan to cover, like the options for building cross-platform software. We're going to kind of talk through the pros and cons of native versus cross-platform, and also the pros and cons of each of the options. We're kind of going to give you our thoughts on what you might want to do in certain situations as experienced engineers on the matter. And finally, we're going to kind of help you choose an option that is right for your product. So, like I mentioned, first we're going to define some of the terminology. First up, we're going to talk about programming languages. These are some of the ones that we're going to mention today that are involved with various different options and frameworks. So we have Swift, Kotlin, JavaScript, TypeScript, and Dart. These are just various programming languages. We're going to mention a couple things about compilers. It's not super important to understand a lot about a compiler, but the basics is that it turns code that a human can read and write into an intermediary format or a machine level set of instructions. They're used for various different types of things, but the two largest reasons are that they are used to check for correctness and also to optimize code in various ways. The next thing we're going to talk a little bit about are the different platforms that we're going to focus on, specifically iOS, Apple's mobile operating system, Android, Google's mobile operating system, and the web. So those are the platforms. I'm going to talk a little bit about what native development is to compare and contrast that with cross-platform stuff. So native development has some various characteristics. For the first thing is that it's almost always compiled. I just talked a little bit about compilers, but that's an important part of it because when you're developing a native application, developers need to go through a step called compilation, where the compiler is compiling the code to machine level code. The other characteristics is that you are using the platform UI libraries and components. So that means that, for example, on iOS, the buttons that you'll use or the image views you'll use are going to be similar to other parts of the apps in the operating system. So built-in apps like the calendar app or the iMessage app also use these built-in platform UI libraries. The other thing that is a characteristic of native development is you get direct API access to various device capabilities and features. For example, on iOS, Apple Pay, widgets on various platforms, and stuff like rich notifications. So beyond just normal regular push notifications, things around showing things when the user interacts with it or whatever. Now I'd like to talk a little bit about the process and tools that are involved with native development quickly. On iOS, we have the programming language Swift, the UI framework Swift UI, or UIKit is more of a legacy framework. And the IDE that people use is called Xcode. On Android, the programming language for native development is Kotlin, and there's a UI framework called Compose that is the modern way to build UIs on Android. And the development environment that developers use is typically Android Studio. So now that we've talked a little bit about what native development is and some of the characteristics of it, we can start talking about what we're here to talk about today, which is cross-platform development. So some of the characteristics of cross-platform development are typically you're going to be sharing a lot of code. So there's some caveats with this, but you're going to have the majority of your code in one code base. You're obviously, I guess, going to be able to target multiple platforms. So with this single set of code, you'll be able to target iOS, Android, etc. The other thing that is important to understand about this is that it's not necessarily natively compiled or run. So in a lot of cases, you'll have an interpreter running on the device or some other intermediary system that allows things to run, the code to run. Kind of like what I was just mentioning with the one code base, there's a notion of write once, run anywhere. However, there are some caveats with that, which we'll get into more. But like I said, you're going to be able to share a lot more code than if you were to have native developers working on the two different platforms. So the other thing about cross-platform development is that there's tons of different options. And these aren't even all of them. There's all kinds of stuff spanning from over a decade old to more recent things. However, with our experience, we've kind of are going to talk about only 3 of them today. And from left to right, we're going to be talking about React Native, Flutter, and progressive web apps. So to kind of start talking about these and kind of defining what these different technologies are, I first want to talk about React Native. This was created by Meta, known for Facebook primarily. It uses JavaScript, so this is a programming language that a lot of web developers use, but it uses that to map JavaScript code to more native UI components for the different platforms. For Flutter, this is a technology created and maintained by Google. It uses the Dart programming language. It was in one of the slides earlier. And the way it kind of works is it's a custom UI rendering engine that is built with on multiple platforms with low-level graphics to kind of render everything for you once you've written your application. Progressive web app is a little bit different than the other two in that you can pretty much use whatever framework you want, web framework you want to build these with some limitations. So you're not necessarily tied into one way of doing things or anything like that. The whole idea around a progressive web app is that you can approximate a lot of native app behavior. So if you're using one of these, it can kind of feel pretty similar to an app in various ways versus just a regular website you might go to on your phone. Some of the ways that happens is like you can save it to your home screen so it can appear as if it was a native app, and you can open it that way. You do get some rich features that are native, such as like you do get access to push notifications, location APIs, and stuff like that. And the other thing here is that your progressive web app will have the ability to be offline capable. So you don't necessarily need to be connected to the internet to use it after you've saved it to your device. And so that includes some features such as data storage. So you do have a limited amount of data storage that you can use to store some of the user's data or whatever. So now I'd like to start a section around the pros and cons of all these different things, like I had mentioned. But first up, I'd like to compare and contrast the pros and cons of native versus cross-platform. And after that, I'll turn it over to my colleague, Andrew. So some of the pros around native iOS and Android development, you can get better performance. Like broadly speaking, when you're writing a native application, your performance is always going to win out when you're developing an app. So this can include how interactions feel on the device. It could be stuff like battery life considerations, how hot the phone gets, maybe stuff like that. Cross-platform technologies add an additional overhead to your apps. You do get more control over the user experience, and it's basically, like I was mentioning before, when you're using the platform UIs and components, it can feel more at home. And both the platform owners play a key role in development of the tools and technologies used for this as well. Like I mentioned, native controls and UX. And you also get to access the device capabilities with these. This is a pretty big deal because you can just directly access them. You don't have to go through any intermediaries or anything like that. When one of the platforms releases a new feature or operating system, you get access to new features first. So in other cases, maybe a framework would have to build a layer between you and the device or the software on the device. But when you're building on just natively, you get those as soon as like the first beta is released. So here are some of the cons to native development. It is almost always more expensive to build. You'll likely need more engineers to target each platform, and oftentimes you'll need more of other things such as QA engineers or stuff like that. To do things in the right way or the best possible way, you'll want to deeply understand the platform user experience and design differences, which can require more design expertise. Typically, since you're not sharing as much of the code, you do have to maintain more work, which is not always something that you might want to do. And a unique problem to having native apps on multiple platforms is the room for ambiguity in requirement specifications. You'll likely end up with discrepancies in behavior between your iOS and Android offerings, which will take time to sort out. I'd like to now turn it over to Andrew to continue talking about pros and cons.
Thank you so much, Ken. Yeah, I'm going to be starting out with some pros of just the cross-platform development portion, and then I'll be getting into cons and also focusing specifically on React Native, Flutter, and progressive web apps in general. So first, like I said, I'm going to talk about some pros for cross-platform development. Cross-platform development typically has shared code. It's primarily written in one language, and changes to that code usually only need to occur in one place. And I say usually because there are some exceptions to that, which we'll get into in the cons. As opposed to native development with one code base, you can eliminate a lot of the room for discrepancy between functionality. It's a lot easier to keep your products across multiple platforms in sync when you only have to write it one time. If your organization already has a web development team, a lot of that knowledge will likely be transferable to the technologies used in cross-platform development. You can save a lot of development time if your team is already familiar using the technology and tooling instead of having to learn something new. On the opposite side, quality and performance of your app tend to suffer in a few ways with cross-platform technologies. Scrolling through content in your app may feel slow, or transitions to new views may seem to stutter. And studies show that an increase in user drop-off happens when using poorly performing or slow software. So you do need to keep that in mind. Cross-platform tech usually results in a product that doesn't play to the strengths of the individual platforms. Now, this does matter less for some applications, and we'll get into more specific examples of that in a little bit. There will always be at least some delay in access to the latest device and OS capabilities that native developers can use day one of a beta release. Cross-platform technologies are always going to be playing catch-up when it comes to adding new features to a native platform, and that can be really frustrating when competitors are able to do something that you don't have the ability to yet, simply because it hasn't been brought to whatever tool set you're using. Even though cross-platform technologies are built with web technologies, inevitably you'll reach a point where platform expertise is required, either due to a shortcoming of the cross-platform solution, a feature that's not available yet, or the desire to more closely match some platform-specific behavior, either on iOS or Android. And the tools a developer uses to build, debug, deploy cross-platform apps do leave a lot to be desired compared to the standard Apple and Google ones. Apple and Google have put forth a lot of effort into their development tools to make it easy for native engineers to build mobile apps on their platforms. And you lose a lot of those enhancements when you take a more generalized approach or use a more generalized tool. Getting into the specific cross-platform options, let's talk about React Native first. It's definitely one of the most popular options, and as such, there's a big community there that can help you along the way. For example, if you encounter an issue or a bug, you're likely not the first, and a solution is merely a search away. React Native uses JavaScript and React, as Ken mentioned, which are very commonplace in our industry. In fact, JavaScript is the most used programming language among developers worldwide. React Native also supports a fast refresh feature, which allows the developer to apply changes more quickly when iterating on a project without the need to recompile it. And Ken was speaking about compilation earlier. With native development, most changes require a bit more waiting and running again from scratch. So having this fast refresh feature can speed things up tremendously, especially if you're rapidly iterating with the design team. If there's any engineers in the audience and they've ever had a designer sit next to them and want to move something 2 points up or 2 points down or change the color a little bit, having to rebuild and recompile and wait for that can be big time consumption. Compared to other cross-platform tech, React Native makes it easier to achieve a closer to native look and feel. One of the original principles behind the development of React Native was to use native components where possible, so you'd get the same experience as if you had developed it natively. And finally, with a little extra work, your code base can be the basis for macOS, Windows, and web versions of your application. Now, the cons, on the flip side, where it suffers the most probably is performance. The marketing touts speed and efficiency, but the additional layers of complexity tend to show up in your finished product. Larger apps can suffer from slow launch times and inconsistent performance between Android and iOS platforms, which make it difficult to find a solution when you're experiencing different behavior between the two. Developers will probably be able to pinpoint the inconsistencies in animation between a React Native app and a truly native one. Animations in particular on native systems tend to change a lot, and it can be difficult or take a lot of time for React Native to catch up, or for you to develop a workaround. And this can sometimes lead to a bit of an uncanny user experience, where your end users will feel like something's just a little bit off. So despite using native components where it can, it's not always possible. So it may end up feeling somewhere a little bit in between a native and a web app in ways you don't always have control over. And some of the larger users of React Native, such as Airbnb and Udacity, have moved away from React Native for app development due to some of the concerns that we just talked about. On to Flutter. Flutter is the more performant of the group of cross-platform solutions we're talking about today. Like React Native's fast refresh feature, Flutter has a similar hot reloading feature that aids in developer iteration. And also like React Native, there's support for macOS, Windows, and web, but also even Linux, so you can run on even more platforms for people that are concerned about that. Flutter has a large library of convincingly native UI components pre-made for you, which does make it easy to iterate more quickly while focusing on your specific application needs, instead of getting tied up in writing the basic user interface, because that can be frustrating when you just want to get your product to market and you don't really care to refigure out how to make a button look good. The downsides to Flutter, however, is that it has a much smaller community than React Native, so it can be harder to find solutions to your problems. Flutter tooling also leaves a lot to be desired. It has a smaller user base and is newer, so there hasn't been as much time and effort put into the systems that allow developers to make great apps. And while Flutter offers solutions for styling your UI to that of individual platforms, doing so requires more platform-specific code, resulting in less code sharing between the platforms. And finally, Dart, which is the programming language Flutter uses, is simply not as common. So leveraging existing engineers in your organization is much less likely to be possible. Finally, progressive web apps and their benefits. They're primarily written in JavaScript and TypeScript, two very popular languages we've discussed earlier. So you'll benefit from the same large communities that you might get from React Native or even native development toolchains. Progressive web apps are capable of running on any platform that has a browser. Websites in general leave users with fewer platform-specific expectations, so they might not have the same consideration for leaving you a bad review. Tooling is very mature, and there are many options to choose from if something doesn't suit your needs. And finally, deploying updates requires no submissions, for example, to Apple App Review. So speed in delivering fixes for production issues and shipping new features is much higher. There's nothing worse than realizing that you released a new version of your app and it's got a critical bug in it or a crash on launch and needing to wait for app review or potentially pull your app from the App Store. With progressive web apps, there's no need for delay. You can just have your developer fix the issue and ship out a new version. However, that's not all fun and games with progressive web apps. Your product won't end up on app stores where a user may be searching. There's no unified location for a user to discover progressive web apps, unlike device-specific app stores that have search built in. Losing out on that discoverability can be a huge hit to your potential install base and has to be a major consideration in your marketing strategy. You'll be less likely to access specific hardware features of users' devices, and it will be more difficult to have a fully online or offline experience, and it will be harder to implement some of the more robust security features. And performance of non-basic apps can be poor. In addition to draining a user's battery more quickly than standard apps, more of these device-affecting metrics are surfaced to the user through the operating system, and users will start removing apps that are affecting them negatively. So time to get in a little bit to our thoughts on what we think. We've been working in this industry for a long time. Naturally, we have our own preferences built on our years of experience. So we're going to share some of those with you today. And we've been living our lives on iOS and Android for the last 15 years. We appreciate the platform nuances, design languages, and embrace their differences. We're enthusiasts through and through. And as such, we prefer and we do often recommend a fully native experience when budget, time, and expertise allow for it. And it's important that you kind of have all three. When deciding what technology to pursue for your new or existing app, it's important to take into consideration not just how much money and time the upfront cost will be, but also the long-term cost. As your app grows in size or changes in scope, applications built with cross-platform technologies are not always adaptable to the needs of your app, while natively ones will largely remain in sync with their respective devices. Additionally, while native development will continue to exist as long as the devices do, cross-platform technologies have no similar guarantee. By adopting their development paradigm, you're assuming the risk of a third party continuing to support that technology. You do have to consider what will happen if the people supporting Flutter or React Native decide to no longer do that. Do you have the capacity to continue support for it? Or will you choose a different option? We've seen many companies, both privately and publicly, reverse course from a cross-platform experience. I mentioned Airbnb before. They have a relatively well-known blog post on the matter and rebuild their app natively. Conversely, some have gone in the opposite direction. They had a native app and they've switched to cross-platform, believing in that promise of write once, run anywhere, which leads or can lead to a heavy drop in review scores in their respective apps. Your mileage with this may vary. That's not to say that a highly polished app can't be built using cross-platform technology. Quite the contrary. There are many examples that demonstrate the quality that can be achieved using one of the cross-platform technologies that we discussed today. eBay, Shop by Shopify, Betterment, and Guideline all have apps that use cross-platform technologies to develop and distribute their applications to a large user base. So how do you choose what option is right for your product? Because each product is going to be different. There are some things to consider, and each product will have nuances that make it important to examine each one individually rather than applying a blanket rule. For instance, what's your target audience? Are they users that are on the go or sitting in front of a monitor? Are they heavy smartphone users or web-centric? What's your budget, and where are you expecting your income? App stores may take a percentage of your revenue, but they can also open you up to be accessible to your targeted demographic. Do you have any in-house engineers that fit with the programming languages used for these various options? If you do, consider playing to your existing strengths that your company has already built, or contract experts in the field, rather than trying to become experts in something new. That can take quite a while to ramp up in experience. Maintenance considerations. How are you going to support this going forward? What technologies are being phased out and might be difficult to hire for in the future? How is your product going to change in the next 3 years? And what platform is going to help you get there? The worst thing to happen would be write your app over the course of a year, ship it, and realize that you need a lot more out of a native experience, or you need to switch to a React Native, and the work that you've done for the last year, you have to throw away. And probably, most importantly, what does the application do? Let's go through a few examples and types of apps and what platform may be best suited to create them. So if your product is primarily data-driven or content-based, like a newsreader or a blog that's light on fluid interaction or graphics, you might want to consider a cross-platform technology such as React Native or building a progressive web app. Users would likely expect your content to be available on the web anyway, so they might be disappointed if you developed a native solution and there was no web-based support. If you intend to have rich animations and graphics or live interactions, we recommend looking into native development first, but Flutter may also suit your needs. If you have an existing fleet of JavaScript and TypeScript web developers, it might make sense to start with React Native or a progressive web app. If your budget and timeline are flexible, you can achieve the best possible user experience by building native. But we'd love to help you make your decision. We'll now take some time to answer any questions you've submitted, but feel free to submit them now as well. If there are any questions, we can answer to narrow down your options for you, or any other questions about the rest of the content in the presentation, feel free to submit them now. I'll hand things back off to Matt and Ken to kick things off.
Thanks, Andrew. We've got a few questions in the chat. I'm just going to take these pretty much in the order that they came in. So if you see your question come up on screen and you have any follow-ups, let us know. The first question is it realistic for an engineer to learn and develop on both native languages, Swift and Kotlin? Either of you can take this.
I can take that. I think it is definitely possible to do so. I think it is it's pretty hard to do that and then also maintain being an expert in both over a longer term. So the answer is yes, but it's not super feasible all the time.
Thanks. The next question is also anonymous. The study you mentioned showing user drop-off when an app has poor performance, who did the study, and can you share any more details on that?
Yes, we can share more. We'll put a link with the other resources we give out. I don't have it in front of me. I have the presentation, but basically some more details about it. Like there were, and there's a couple that I've looked at, but one of them, it's like 70% of users have reported deleting an app because of slow performance, which is a form of drop off. Another one is like if every additional second is like 7% of users will drop off for a loading of a request.
Right, it massively affects your ability to both engage with your current customers and retain those customers if every time they open your app, they're waiting on loading spinners.
Yep.
Next question is someone who's heard a lot about VS Code and is wondering whether VS Code can be used with all or some of these technologies.
That's a good question. So VS Code is kind of like how I was mentioning earlier, Xcode or Android Studio is. It's kind of a development environment or IDE. The answer is yes. I've personally used it to develop Flutter apps, and they have like a Dart plugin, which is the programming language, as I mentioned as well. So yeah, I mean, and VS Code itself can edit pretty much any code file, and it has pretty good support for at least Dart from my personal experience. But I would say almost certainly JavaScript as well.
Great. Going through these pretty rapid fire. The next one is, I'm just starting to explore mobile development. Which language do you think I should learn? First of all, congrats getting into the field. But what should someone learn first?
I guess it really depends on what your goal is and what you want to build. I think looking back through some of the slides that we had before, like consider those things, right? Like, do you want to build an iOS app? Are you passionate about the iPhone and iPad or whatever? If you want to build something that literally anyone in your life can use, maybe consider learning JavaScript so you can do React Native or build a progressive web app, especially if it's like a more hobby type situation. So yeah, I guess it really just depends. So yeah, I know that's not super helpful, but
No, I'll just add on there, like exactly, like what are, if you're getting into it, are you getting into it for a career reason? Are you getting into it because there's something that you're excited about personally building and using? All these things matter. And so when I got into this field, like 15 years ago now, it was because I wanted to build things that didn't exist yet on the iPhone. And so for me, it was a natural choice of, okay, well, I'm going to learn Objective-C at the time and do this on iOS. But things are very different today. And so if you're doing this because you want to be able to get something out there worldwide, for instance, then you might want to learn Android first because Android phones are used much more worldwide. If your audience is primarily in the US, you might want to learn iOS first. Or if you need to be cross-platform at launch, you might want to learn one of the cross-platform technologies. But anything that you learn, some of those skills in learning programming and learning what's possible on devices will be transferable at the end of the day if you want to pick something else up. Another question, and some more are rolling in as well. If I start with a progressive web app, how long would it take to turn that into an app? And can I reuse the code?
Andrew, do you want to take that one?
Yeah, sure. That's unfortunately, I might have a relatively unsatisfying answer to that. If you start with a progressive web app, how long would it take that to turn that into an app? I'm going to make an assumption that you mean turning it into a app on a device, like a native app or a cross-platform app. That is entirely dependent on how big of an app you're making. If you make a small app, it would not take very long to turn it into an app. If you make a really big one, it would take a long time to turn it into an app. Can you reuse the code? If you're making a native app, unlikely. There are some shortcuts you could take that would probably have not a great user experience. Like you could shove a web view either on iOS or Android that would essentially just present your progressive web app in an application. That's not a great experience for the user and probably wouldn't turn out very well. But that's one way you could potentially reuse code. Otherwise, you could reuse code if you were using the same language as one of the other cross-platform solutions, like you were using JavaScript to write your progressive web app. You could reuse some of that in React Native, which also uses JavaScript. Hopefully that answers your question, but unfortunately it sort of boils down to it takes about as long as the size of your app, and you can sometimes reuse code and sometimes not. Fortunately, with code reuse, sometimes it's not as difficult to translate it into a different language as it was to write it originally. Usually there's a lot of good like one-to-one kind of comparisons between programming languages. So it's more about just kind of learning the new syntax and translating what you already have.
I'm going to skip. Thanks for that answer, Andrew. I'm going to skip to a follow-up question from someone who asked a question about learning a technology. The follow-up is, I want to have the best chance of getting a job in the field. Is there one iOS, Android, React Native that's more in demand than any of the others? And I'll leave that one to you as well, Andrew.
That's a good question. Between iOS and Android, I think iOS is certainly more in demand. However, learning something like JavaScript is more fluid. If you have the best chance, yeah, it's transferable. So you could use JavaScript to build progressive web apps, or you could use it in React Native, or you could use it in standard web development. There's a lot of techniques or areas that JavaScript has that you can apply to multiple fields within technology. Whereas learning something like Swift currently is basically used on iOS. Technically, you can write Swift code on the server, but its adoption is pretty low. And I don't know of any larger companies that are doing it in a realistic manner.
Okay, next question comes from a friend of the company, Kevin Grant. Are there any trends in mobile tech choices among SaaS companies? I can start answering this one, and if either you want to add in, that's totally fine. SaaS, software as a service companies often do end up needing to have an app at a certain point. we use a lot of SaaS companies here at Lickability to do what we do. So we do pay attention to how their apps are built and what they're good at. And some of them were actually called out in that slide about cross-platform apps, like Guideline, for instance. That's our 401k provider. It's a SaaS, and it does use a cross-platform app. That said, I think the broad trends that I've seen over the last, I think, 5 years are folks starting with Electron on desktop, then realizing, hey, maybe we can reuse some of this Electron code in a mobile app, shipping that, and then seeing their customers sort of disappointed with the performance and way that app has worked out. So we see this with Linear, right? One of the most popular issue trackers, the issue tracker that we use on a lot of our projects. They have a progressive web app that is just sort of a scaled down version of their main product, and the performance is really, really rough. And so over the past few months, they've been hiring a native team on both iOS and Android to replace that app, and a lot of customers are clamoring for that. So at a certain point in scaling your SaaS, you might get enough demand from customers to rebuild natively. That's the broad trend that I've been seeing. Anything that either of you want to add?
No, that's basically all I had. I mean, you can see Slack and Zoom sort of follow that same trend as well, with it's starting to think more about native solutions, but starting in a cross-platform way.
Two more questions, and I'll give time for someone to submit one last one after that, because we do want to get you out of here on time. Have we seen much interest in using Kotlin multi-platform for cross-platform development? They link to the documentation. And similarly with the new Compose multi-platform, which is from JetBrains, it looks like. Ken, do you have some experience around this?
I have experience. So yeah, on one of our previous clients, we used Kotlin multi-platform extensively, I'd say, and in multiple projects. So let me actually take a step back and explain what Kotlin multi-platform is. Kotlin is, like I mentioned before, the language that you can use to build Android apps. However, there is a framework technology called Kotlin multi-platform, where it will actually give you bindings for both native platforms. So you can build a Kotlin code base and not UI, but specifically your logic, maybe your network requests, your data storage, whatever else you're doing in Kotlin. And you can kind of call into that from either iOS via Swift or Objective-C, and then obviously from Android with Kotlin, just Kotlin to Kotlin, as you would otherwise. And so, yes, we use that pretty extensively, including contributing a little bit to the Kotlin code base itself. I think that that is another, well, we were talking about trends, but like there's another trend with that going on. It's a little less adopted than the other things we're talking about here today. But I think it's a really decent option if you do want to start have this native apps, but you don't want to duplicate as much code as you would have to if you were just writing everything on both platforms. Now with Compose multi-platform, I don't have any personal experience with that. We were not using that. It seems interesting. I think it'd be really cool if that ends up working out. It'd be another great thing that maybe version 2 of this webinar in a year, we have a Compose multi-platform slide.
Well, one of the things that concerns me, I've never heard of this, but just looking at the website, they don't have any links to apps that are on the store that use this on the site. There's a quote from one of their own employees that it's great, but they don't actually have. It doesn't seem like to have been adopted by anyone in the market. So I never want to be recommending a technology where I would be the biggest consumer of it, and it seems like it's just a little bit early for us to recommend something like this.
That is really new. The Kotlin multi-platform is a little bit more widely adopted, but the Jetpack multi-platform or Compose whatever is very new for sure.
And to sort of piggyback off of that, like the iOS portion of the Compose multi-platform is still technically an alpha. So it's not something that I would recommend somebody that was looking to start a new application, build it, and ship to the App Store for a bunch of users to get in use of. You want to be really confident that your choices aren't going to come back to bite you. If you were using this to explore personal projects or expand out things there, it's definitely something to look into. But for the
Prototyping.
stage that it's at right now, I wouldn't recommend it to anyone that was looking to ship an app to the App Store over the next year.
Last question. Great point about potentially using a WebView to migrate from a PWA. Are there any benefits to a WebView over a PWA generally? The main benefit is distribution. So getting access to the app stores as a place to rank in terms of folks searching for apps, being featured by Apple and Google. There isn't a similar way to get distribution on the web other than search engines. So that's the benefit of shipping your PWA and then also shipping a wrapped version of it to the app stores. Over time, then you can also start to migrate parts and pieces of it into native, and that's another benefit that you get, that you could progressively enhance the progressive web app that is inside of that native shell. And with that ends our questions. So let's just go to our final slide here. I want to thank all of you for being here. And of course, I'd love to talk to you more about any of these questions or other questions that we didn't have time for, and to work with you on whatever you're thinking about building your application, designing your application. So you can always reach us at lickability.com/contact. Finally, I've updated the resources section of the Zoom webinar to have some of the links to our website, some of the articles that we mentioned, and a full copy of the slide deck. So feel free to share that within your organization. And if you have anything else that we can do for you, always happy to chat. Thanks for being here. Really appreciate it. And thanks to my co-presenters, Andrew and Ken. Let's give them all a round of applause as well. Incredible work. Thanks, everybody. And I'm going to end things. Have a great afternoon.